Alrighty. Man, is that the heating and cooling? It's so loud. I don't know what that constant fan noise is. That's awesome. So I did hear though, back in 2020, when like everything hit the fan, um, some of the rooms in this building have negative pressure. So the air would actually be getting actively pumped out of the room, which is really cool. So like for the couple in-person things that they had, they put them in all of these buildings that had the negative pressure. Uh, so like air is actively getting circulated much faster. So maybe that's what's happening. We'll pretend. We'll pretend. All right. So we got a couple things today. We're going to finish up talking about types here. I did want to talk about the lab a little bit. I think it was pretty straightforward. You folks did pretty good on it. Not too much trouble there, but did want to go over it again. Generally, I'll try and go over the lab. The goal is you get it done before you walk out. I think everyone was able to walk out on time. That was great. Sometimes they take a little longer. Sometimes they're a little shorter. That's just sort of how it goes. But I want to be able to show you how I would go through it pretty quickly. We might not be able to touch on everything, but for a little bit here, we'll try looking at that. So let me go and fire up PyCharm here, and we'll go grab that lab assignment. I think part one was easy, right? That was just a bunch of prints, no big deal there. But part two, right? How many credits, how many more you needed to take was the rounding bit, right? That we needed here, and then the total cost. Now, total cost, I think we were just computing we didn't really have a good way to compute that, right? This is not super clear of how that worked. And do we just go by credit cost? Because technically there's like a slight discount if you take more than 12. Know that? I thought that was like a big advertising selling point that they had. Dearborn cost per credit. All right, I'm getting some weird looks, so we'll go take a look at this. Let me fire up a project here. So we'll close, file, new project. And again, I'm going to put this in my main class repository. You'll put them one project per repository, one lab per repository, just to get you some practice with the workflow. So you accept the assignment, you clone the repository, you make the project, you commit and push. And it will help keep things organized, which will go pretty well. So we're going to call this one Lab 0. Great. I'll go ahead and make that one. And I'll do it in this window. Okay, so for tuition and fees here, there actually is a block tuition assessment. So if you take 12 or more, you pay for 12 credits, and that's it. You can take 15, you can take 16, you can take 18, whatever, up to like whatever, which is great if you have no life. If the only thing you have to do is take classes, you can take more. The downside is if you have anything else going on in your life and you can't dedicate everything to school because you have jobs and family and responsibilities and whatever here, you're incentivized to take more classes than you can handle because 12 is really a full-time load. Right? The general expectation with college is for every credit you have in class, you have 2 hours worth of work outside of class. So at 12 credits, that's 12 hours in person plus 24 hours of extra work. That's 36 hours a week minimum, right? Sometimes it's more, depending on what's going on. So that's already a full-time job at 12 credits. When you start getting to 15, right, then you're at 15 times, so you're at 45 hours. You're going to take 18, you're almost 60 hours a week just for school stuff. It gets nuts pretty quick. But there's a block assessment here, right, depending on what we're doing. So we need to do a little bit of arithmetic here to be careful with that and make sure we're getting the right number here. So we're going to have a couple things, right? We're going to have credits. This was going to be here's this. How many credits are required for their degree? Right? How many do you need? So this was credits required for degree. It's probably an integer of an input of how many credits do you need? And then we're going to have how many we've completed, right? So credits completed is an int of an input. How many credits do you have completed? And then we were going to have average, right? How many credits we take on average per semester. So average credits per semester is an int of an input. How many, can't spell, credits do you take per semester? Again, it's a little long here, but only because I'm zoomed in a bunch on my screen here. It should be fine on your screen. Shouldn't look too bad. right? And now we can do some arithmetic. Now, the arithmetic here gets a little weird because you're going to pay this amount if you're taking 12 or more, and we don't really have a way to do that yet, right? So we can calculate both and just see and tell them, pick the right one here. Is probably the only option we have for that. Again, whichever way you did it, perfectly fine. You don't need to go and redo the lab. I just want to show you, hey, there could be two different things that happen yet. And that's next week's topic. What do we do if there's two different things that could happen, right? How do we make choices? And that's the last bit we need for the first project, project 0. We'll get to that on Monday. So we can calculate it then. We can just say, hey, really then it's going to be, we can print, you have, and then we want to calculate here. This is going to be my credits remaining. So I probably, if I'm going to do this number more than once, I probably want to have a new variable for it. So it's credits remaining. It's going to be my credits required minus my completed credits. Right? That tells me how many I have left. Right? If you came in here with 12 credits already, great. You now don't have to take those 12 credits. So that'll be my credits remaining divided by my average credits per semester. And really, we want all of this rounded up because you can't take half a semester, right? Remember, I think we talked about rounding a little bit. There's this cool math library. We can import math. And we can say math.ceil to round up. Ceil like ceiling will round up. I think we talked about that real briefly. Does that ring any bells? Okay, good. I say a lot of things every week, so sometimes I forget. So that'll round up how many semesters you have left. Can I shrink it a little bit? Is that still, you can still see that okay? It's getting a little large. Semesters left, right? And then for cost, then, we have one of two things, right? If they're taking less than 12, they just pay $606 a credit hour. Sure. If they're taking more than 12, they're going to get a discount at some point. We have to figure that out. So depending on what's happening here, we'll say, if are taking less than 12 credits per semester, it will cost about, and then this arithmetic is not too bad, right? That's just going to be my credits remaining times 606, right? That's the per credit hour cost. Not to mention that the additional assessment, so your junior and senior level classes, 304 level classes, cost an additional $125 per credit hour. But they don't tell you that early. I mean, it's on the website, but so it's not just a flat fee per semester for tuition once you get to junior and senior level classes. Sorry, I didn't make the rules. Okay, but essentially it's close. If we wanted to say maybe half of them, we would cost an additional amount. Maybe that might be a better estimate, but I don't know. It's fine. That's probably more work than it needs to be. Okay. Okay, and then we could do the other calculation. If you are taking more than 12 credits per semester, it will cost about, now this arithmetic is a little harder here because there's a couple more things going on, right? Because we have the per semester cost is how many semesters you have left, but you want the whole semesters. So we want actually math.floor, we want to round down here. Take that number. So if you have 5.5 semesters left, it's really 6 semesters left, but 5 semesters at 12 or more credits will cost this much. The couple credits you have left, your very last semester, you don't pay the full block amount, you pay the 606 amount. Right? So if you get to your senior year and you only have 7 credits left your last semester, you don't want to pay 7,000, you want to pay 7 times 606, right? So we're going to take that rounded down times then 7272 plus then we want to add in here the what's left of that. So the remainder, right, that's modulus. So my credits remaining modulus my average credits per semester. What's left over? Do I have 3 credits left over? Do I have 7 credits left over? It could be 0. Like 0 is okay. Multiply that by 606. Now, I did at one point in time have someone argue with me, and it blew my mind that a college student would argue order of operations, because I don't know how they got through math classes, but they said, hey, it's parentheses, exponents, multiplication, division, addition, subtraction. So you have to do multiplication first, and then you do division. And I just looked at them like they're crazy, because they were crazy, right? Multiplication and division have the same level of precedence. You just have to have a word first. You don't say multiplication, division. There's multiple things at that level. So modulus is a division operation. So modulus has the same level of precedence as multiplication and division. So you do them left to right. So this will happen first, then multiply by 606. It's not average credits times 606. Then take that result, modulus credits remaining. Right? We go left to right. I don't know why someone was confused about that and had gotten into calculus, but holy cow, I was blown away. So if you want, you can add parentheses, right? Parentheses never hurt to be explicit on, please do this first. Even if the computer already will do it first, you're welcome to ask it to do it first, right? The computer's not going to get sad and upset that you're asking it to do something, right? It'll do it. It was going to do it anyway. It's just going to ignore your parentheses. But for people looking at your code, this makes it nice and explicit and clear that, okay, this chunk happens first, then we do this. So you're welcome to add it in here. Right? Nothing wrong with that. So we have two different calculations then, right? One at per credit cost, if you take less than 12, one at the block cost plus whatever remainder. Now, if the remainder here is 0, 0 times something is still 0, right? We've not changed anything. So if you have a perfectly even divisible block amount, average amount, great. You can just pay the 727 per semester and be done, right? But if you have 1 to 11 credits, your very last semester, you don't want to pay this block rate, right? That's all. So we can calculate it both ways. Now, we've done a bad thing here. If I have 606 here and 606 here and 727 here, like those numbers don't mean anything aside from I copied them from the website here, right? And I'm probably going to forget what they mean later. So these are what we call magic numbers. They're a number that has a meaning, but I haven't communicated what that meaning is. So the right thing to do about that is to make them variables. Now, there's a convention for variables. We want to call them constants. We don't want these values to change, right? Here's just a constant value. Like imagine pi. Pi is a constant value. It never changes. So if we want constants, we would typically name them in all uppercase. This will be cost per credit. So all uppercase for my variable here. And now I can multiply by the variable name cost per credit. And now my code is much more readable because you don't see something times 606, you see something times cost per credit. And the other really good thing here is because I have a variable here, the odds of me typoing that go down. So I only have to enter 606 one time. If I have to enter 606 7, 8, 9, 10 times, the chance of me screwing that up is really high, right? I type the wrong keys all the time. And just like if you've ever written an English paper, you say and way more often than we ever should. Now, thankfully, Microsoft Word is good at finding that nowadays, but things come out when we're typing that we have no intention of. And it's really hard when you're proofreading to find it because you know what it's supposed to say. So like 606 looks a whole lot like 600 or, 61, like all these things could look very similar and you're just going to miss it. So this is a constant value, constant variable. The idea is we don't want it to change, right? We want to give it a value and we can use that. So we avoid magic numbers. And same with 7272, right? I want to take that and I want to use, this is cost per semester max or something like that. I don't know, some sort of nice meaningful value here, right? Cost per semester max. So now it's much more clear what the code's trying to do because I have variable names for it, right? And that's why we say the code is for people. We write code so we can read it and other people can read it, right? It just so happens that Python can read it too, right? It's not worth a whole lot if Python can't read it. But the way that we write it, the way that we format it, the layout of it is so that people can read it. That's the primary goal, right? We want to be able to see what's happening here. So let's give that a run. So if we need 120 credits, and we'll just say we have 50 done, that gives 70 left over. If we're taking 10 per semester, right, it's going to cost 42,420. That's 70 times 606. I think that math checks out with 7 semesters left, right? At 10 credits, that's perfectly even, nothing had to round. If we were doing if we're doing the block rate, it cost me more, right? Because we were paying 7272 per semester times 7. So we don't want that, right? So you want the lower number, which is nice. So let's try it again here. And let's say if we did 120 credits, we have 50. It means we have 70. If we take 13 credits per semester, right? That's 5 point something, right? So, excuse me, you'll get a slight discount because 5 semesters you pay the block rate, and then the 6th semester you pay the remaining 5 credits worth, right? I think 5 times 13 is 65, right? So 65 out of the 70 we pay the block rate, and then the 5 left we pay the per credit rate. So I think the math checks out. And again, if you don't know what the math should come out to, we've got no chance of making sure our code's right. The hard problem of programming is making a complex problem, breaking it down into simple steps so that we can tell a computer how to do it. We need to be able to understand what it's supposed to do so we can tell the computer to do it. That's the goal. In the other class, I wanted to ask, well, how do I know if it's right? Well, you have to go through the steps. And you should know if you put this number in, this number comes out. If you can't do that, we've got no chance of writing the right code, because what is the code even doing at that point, right? We need to be able to get it into English and be able to do it, on paper, essentially, right? Like talk through it. What are the steps we have to do this here? All right, does that make sense for the lab? All right, awesome. I'll go ahead and commit that one here. Oh, I forgot this one here. So this is more chapter 3. This was for the other class. I forgot to commit and push. I'll do ours here. All right, 1501. Here is lab 0. And again, I see my main PY file. Looks like it has everything I need. I'm happy. I can commit and push. All right, we okay so far? All right, so let's get back to chapter 3. So let me go back and open my recent chapter 3 project. And I'll just keep going here. So we got through lists, we got through tuples, right? We got through indexing here. Okay. So now we're going to move on to dictionaries. Dictionaries are one of the most useful types in Python. We're going to use them all over the place because what they let us do is create these key value pairs, which sounds like a bunch of nonsense, but you just think of a dictionary for a minute. The dictionary has a list of words, and each word has an associated definition. So the key is the word, the associated value is the definition. That's a dictionary. In Python, we're going to give a list of keys. Here's the value, here's the key you're going to look up for, like when you flip through a dictionary, hey, find the word strong, and then find the associated value for that, find the definition. So we can give it a list of keys, or a set of keys, if you're going to be specific, with associated values. That's what a Python dictionary does for us. So, and it doesn't have to just be strings, right? You can be for anything. So Python dictionaries use curly braces. So dictionaries create a set of keys with associated values. So I can say, hey, this is my, what do I have here? Here's classes and names then is equal to set of square braces, or a set of curly braces. Now, this will start an empty dictionary, or if we know some already, you can start giving values, right? So you can be empty or you can give values. So if we know what the values are, I can say, hey, the key here is going to be CIS 1501. That's the key. Here's the class. The associated value will be the name of the class. So you say key colon value. I didn't come up with this. This is just what it is. So you say key colon value, and then the value will be CS1 for data scientists. Right? That's the first value, the first entry in my dictionary. And then we can add CIS 2001. So key colon value is going to be CS2 for data scientists. Right? Scientists, something like that. I can't spell. Okay, that went away. Right? So now I have a dictionary. Here's the key, which is the course name and number, or department and number. The associated value is the name of the class. So if you just want to print the dictionary, you can get this back out pretty quick. Eric, oh, that's right, cat. Okay, let me just stop that. We don't need that. Let's just run just this bit here. Execute selection. Here we go. So when it prints out, it basically what we gave it prints out. Key colon value, key colon value. The other cool thing you can do with dictionaries is you can add values here. So classes and names. Now to add something here, this is add a value or add a key and associated value. You use this square brace syntax. So before square braces was for index. We also use square braces in dictionaries for key of. Right? So square brace, I don't know, means key of. It doesn't mean index. It means the key. So what other class are you folks taking that we should add to this dictionary of classes? Calc. So that's MAT 150. Okay. And then the name of that is that Calc 1? Calculus 1. Right. Or sometimes you'll call that derivative calculus. Derivative calculus. Is that, I don't know if you've ever heard that. I'm sorry, I'm doing the wrong syntax. Oh my goodness here. All right, so key of, and then we say assign a value, associate a value with that of Calc 1. We'll just call it Calc 1 because that's easier. It's really derivative calculus, okay? So this is to add a value and an association. This adds a key of Math 150 with the associated value of Calc 1, right? Then let's go add another one. What other class have we taken? So is that P, is that 4 letters? Is this one math? Is it 4 letters? Yes, it's just 3, whatever, it doesn't really matter. 125? And what is that? Introductory physics. Physics, sure, probably right. Cool, so we've added some values here. So now I can print my class as the names dictionary again, and we've added values. So I print it off. Now we see the first version just had the 2 classes, and the next one has more classes, right? Key, colon, value, key, colon, value. So you don't have to know them to start, you can go add them one at a time. Now, here's the weird thing. So this syntax here also is for updating. So update a key, or update the value associated with a key. Associated with a key. So I can say, hey, classes and names, key of Math 150. Let's change the name. Let's say instead of Calc 1, we want to call that derivative calculus. Derivative calculus. So this same syntax that adds a key also updates the value. Now, I think this makes sense if we pause for a minute to think about it here. So dictionaries, the keys have to be a set. They have to be unique because you can't have multiple keys, right? Because you have a value associated with the key. Now, you can have multiple values, but in the dictionary, there's only one key, right? There's only, the word is the word. It might have multiple meanings, but it's still just one word. So you have a single key, and then we can change the value associated with it. We'll say, okay, instead of Calc 1, let's call it derivative calculus. For Calc 2, we'll call that integral calculus. For Calc 3, we'll call that multivariable calculus. Why not? Why do we use 1, 2, and 3? I don't know. Someone came up with it. And sure, that's fine. It doesn't really matter. We can just go with it. Right? So it's the same syntax. We say dictionary key of, here's the key, change the value associated with it. Is that okay so far? Now, the other crazy thing is we use the syntax for a third thing here. So if you just want to print the value associated with the key, so to get the value associated with the key, we use that exact same syntax. So we'll say the name of Math 150 is, and we say classes and names, key of Math 150. Now, there's no assigning happening here. There's no assignment operator. So this syntax, say key of, gets the value. If you go and assign it something, it will add or update, right? So really, this is add/update, right? And this is just get the value out. So we could get values out of lists by syntax, by index, and you could assign values in a list by index. Same thing here, right? You can get the value out by key, or you can assign the value by key. Right? So it sort of works the same way lists did, but it's key value pairs happening here. No, I didn't want all of it. Shoot, I wanted just this one here. I got to remember to do that every time. No. No. This one. Is that it? Yeah, the name of Math 150 is derivative calculus. We got it back out. Now what happens though if you screw this up? You just say Mat 150. If there is no key that exists there, and we give that a run on file in Python console. No, I didn't. Man. My goodness, friends. I'm having a day. Execute selection. There we go. That's what I wanted. Just the selection. Execute selection. No, what? All right, hang on, let me stop it. Try it again. Just the selection. Here we go, okay. There we go, okay. We are finally getting there. We get a key error and the program crashes. The key error is Mat 150. It's not the most helpful error, but that means there is no key in the dictionary of Mat 150. So you have to be careful, just like we could get list indexes out of bounds if we tried to get an index that didn't exist. If you try and get a key that doesn't exist, it crashes on us. Right? So you have to be careful that you use keys that do exist when we're dealing with dictionaries. Those key value pairs. Key value pairs. And they got a bunch of fun examples here. Keys modifying. Okay, cool. All right, so a couple recaps of types, right? We had integer types, we had float types. Whole numbers, numbers of decimal places. We had sequence types. Dictionary is also another fancy term for a mapping type, right? It maps a key to a value. So we've got types there, right? We have strings, which are sequence types. We have lists, which are sequence types that are mutable. We have tuples that are sequence types that are immutable. We have sets, which are mutable, unordered. Now, I don't know if you remember much about sets. When we did the set syntax, it also used curly braces. Did we do any of those? I don't remember if we did any sets. Did we do any sets? I don't think we did any sets. No, did we skip sets? We might have skipped sets. Okay, so a set is a dictionary without values. So that's the shortcut here. It uses the same curly brace syntax. You just don't give it associated values. You can have just keys, right? It's a unique set of keys. So dictionary is that with associated values, these key value pairs. All right. Converting between types. So to get from one type to another, Python's pretty good. Int will convert something to an integer. Float will convert something to a float. We've done this already with inputs, but you can do it with other numeric types. So you can give int a floating point value, a number with a decimal place, and it'll turn it into an integer. When you do that, what do you think happens to your decimal place? It doesn't round. It just truncates. It goes away. So 4.9, that's a good guess though. So 4.9, so print int of 4.9. Say 4.9 as an int is int of 4.9. We just lose the decimal place. It's like, okay, what part fits in the integer? Goodness, right? Just the integer part. So any decimal remainder gets thrown away. That's all. Float, you can convert integers to floats if you want. You can convert strings to floats, sure. You can also take something and turn it into a string. You can give it some value and turn it into a string, right? When we did our inputs, so if we said, hey, I wanted an input of, I don't know, and we wanted two values. So when we did prints, you can comma separate things, right? We could say, hey, print, I think we had some values up here, right? What we have, yeah, scores. How about scores of 0, comma, some text. You can comma separate in a print. With an input, you can't do that. Right? You'd have to say scores of 0 plus to concatenate some text. Now, usually this will work, but it gets a little awkward here because depending on what we're doing, right, we might get some weird results. So if you want to be explicit, you can say, hey, give me this as a string, please. Now it's a little happier. So notice I had this like warning here, this little yellow line. Expected type int got a string instead. So if we do the scores, enter a score, append the score. I don't want to go through all of that. Hang on, let me just do test numbers. So list of 1, 2, 3. Let's do that. Right, if we get our test numbers, this needs to be an input here, so I don't know, answer. Let's run this one here. We get unsupported operand types for plus, int, and string. You can't add an int and a string, right? When you comma separate, print's like, okay, sure. So print implicitly turns everything into a string for printing. It's essentially adding that str, the string conversion, everywhere. With input, we don't get that. So we have to say, hey, give me a string version of this, and then concatenate, right, smush together this way. So occasionally you'll have to convert to string explicitly, so we get that result out, right? One, some text, that's my input now, whatever. Right, so sometimes you have to convert to strings. So you can convert to strings. All right, binary. We talked about binary briefly, right? We looked at the powers of 2 with bits and how many things we store. Binary is really fun, really fun. Eventually, everything is down to bits and bytes. Now, this is why, if you've heard anything about quantum computing, that people are really excited about it. Honestly, it hurts my head, and I don't really understand it, but that's okay. So the idea with bits and bytes is that everything is powers of 2. But if we can have these qubits, these little quantum bits, they can hold more than a 0 or a 1. As like 8 different states or some crazy thing like that. I don't even know what it is, right? So for 8 qubits in a row, it's not 2 to the 8th, it's 8 to the 8th. So the amount of information you can store in 8 of these things is magnitudes larger, right? I don't even know what 8 to the 8 is. What's that? 8 to the, hang on, here's my better calculator. 8 to the 8th. 16 million in just 8 qubits versus we can get to 256 possibilities. Now imagine stringing 30 of those together or 50 of those together, right? Just the sheer amount of information you can contain in just 50 qubits is crazy. Somehow they'll let you solve problems really fast. And that's the part that I can't wrap my head around, or how that works, or how you can measure something that changes when you measure it, because physics is hard. Sure. The really smart people understand this sort of stuff and they're excited about it. So great. We'll let them be excited about it. The practical side of things, which for better or for worse, I care about practical applications of things, is the way that encryption works on the web nowadays relies on prime numbers and factors of prime numbers. And factorizing very large prime numbers is really slow in trying to find these sorts of values. So the only reason encryption works is because it takes a really long time to break it. The idea is that once quantum computing is like an actual everyday thing or usable by people who want to use it, today's encryption is going to be meaningless. So people are researching how do we do encryption post-quantum world. And pretty sure it was like one of the first proposals for it got broken really easily and everyone laughed at the people, which is a little bit sad, but this is why we have people with math PhDs trying to research this sort of stuff to come up with a good encryption algorithm and putting it out in the world for people to poke holes in. Right? That's a good process. Right? We want to try and make sure it stands up here. But so what I've been told by people who know things is that anything that's encrypted today will not be encrypted in the future at some point. And there's just nothing we can do about it, which is a little bit depressing. But sure, I mean, people have to store that encrypted information for long enough to actually care about, and if it's old enough, like, do they really care? That sort of thing. But it'll be an interesting new world once we get there with quantum computing. All right, bits and bytes, lots of fun. All right, that got us through. Okay, so we got through most of chapter 3. Very cool. Do you want to start looking at branching just a little bit? We don't have to get very far, but I can give you enough that we can get the first part of the project done. How's that sound? All right, you guys sound excited. That's great. So the idea with branching, right? And if we think back to this lab idea here, it's probably the easiest one if we go back to that. So let me go save this here. So here's more chapter 3 complete. Sure, something like that. Commit and push. All right, I'm going to go back and open the lab exercise because this will be the easiest place for that. When we did the lab, we said 2 things could happen, right? Either you take less than 12 credits or you take 12 or more, right? And I think in English, we said if you take less than 12 credits, this thing happens. Else or otherwise, the other thing happens. So in coding, it's if and else. So if this is true, this happens. Else, this thing happens. Still pretty much English. So we can put an expression in here. We can say, okay, if this is true. So we'll say, if my average credits per semester is less than 12. And then we use a colon. So we add a little more syntax here. So if average credits per semester is less than 12, colon. Now, Python gets a little weird about this now. Everything that I want to have happen if this is true has to be indented underneath the colon here. So I'm going to grab this line here and hit tab. Everything that's tabbed in here, and you can sort of see there's like a real faint line here to show me where this indentation is here, belongs to this, and we call these blocks of code. This is a block of code will run if this is true here. Then this will happen. Okay? So, okay, is it less than? You can say is it less than or equal to? You can say it doesn't equal. Now, with equals here, you can't just say the single equal sign. Because remember, that's the assignment operator. That gives a new value. So if you want to say, does a value equal something, you have to say double equals. Yeah, I didn't come up with it, but that's what it is. So equal equals really means equals. Sure. I'm sorry? So that's the assignment operator. That changes the value of something. So like this equal sign is the assignment operator. It takes the value on the right, assigns it to the variable on the left. So we can't just use a single equal sign because it's like, okay, now I'm going to put 12, assign 12 to average credits. That's not what we want to have happen. So we have to use double equals here. Again, for our purposes, though, we want less than. Okay? And then any other code we want in here, we can write in here. So print more code that runs if average is less than 12. Sure. And anything you have in here, as long as it's indented, will run if this is true. If it's not true, Python completely ignores everything in that block because it's not true. We said only do this if this is true. Right? So then to get the else bit, then we just say else colon. And then anything we want to have happen if it's not true goes in here. We can say, okay, if it's not that, else this. And then you just continue on. Once we're done then, now we can print other things. Thanks for running our calculator. Right? So once you're done indenting, once that block is done, we come back now. So regardless of if this is true or false, this line of code will run eventually. Right? But these lines of code will only run if this is true. And this line of code will only run if it's false. Right? So what you have to put in these if expressions, they're Boolean expressions. They have to be something that will be true or false. Right? Now, Python gets a little weird. Python is a truthy language. And what that means is everything is true or false. So you have to be a little bit careful here, because I can just say if average credits per semester, and Python says, oh, sure, I know what that means, which is really weird. So in Python, anything that is numeric, integers and floats, and anything that holds a number value, if it's not 0, it's true. A 0 value, Python interprets as false. So Python will let you do some really weird things if we're not careful, like if average credits per semester. I didn't finish typing here, but Python's like, okay, sure, I'll run. So we just need to be careful to like finish all of our expressions here, right? So this expression now is true or false. If it's true, these lines of code will run. If it's false, the else lines of code will run. Now, that's great for an either or. What if I have 3 different choices, like our party? What if I have pizza, or I have sandwiches, or I have beverages, or whatever we came up with? Ice cream, right? I think we had ice cream, right? What do we do then? Well, you can have multiple choices. Now, this one is just an if or an else here. That's fine. Let's ask one more choice here. So let's ask them for our, I don't know, year in school equals an input of enter your year in school. And again, I'm going to give them a hint here. Like I want them to enter freshman, sophomore, junior, senior, something like that, right? I don't want them to enter one or first or I don't know. Like now, we have no control over that. We can't fix it if they give me bad input yet, but we'll get there later. So now if I wanted to say, okay, if my year in school is equal to freshman, I can do something. So if the value entered is equal to the string freshman, let's print something. I'll say welcome to UMD. Sure. Now, if it's not that, but it's something else, we'll say else if, and the fine folks at Python said typing else if is too much typing here, so we shortened it to elif. Elif is short for else if. Oops, sorry, I bumped that. My cord here is real sensitive. So I can say elif, my year in school is equal to sophomore. And maybe we print, hope you found some cool clubs to join. And then elif, your year in school is equal to junior. Junior, print, did you have an internship yet? Something like that. And then how about elif, your year in school is equal to senior. We could say print, you are almost done. Now, if it's not this, and it's not this, and it's not this, and it's not this, I can have an else. The else is the default, or it didn't match any of the things above. Now I can say print, I don't know what you entered. Right? Sure, it didn't match anything. So it's either this, or it's this, or it's this, or it's this, or I don't know. It didn't match any of them. So we can use these to find a match for what it is. So, and this is what you'll do for the project. For your type of food or your whatever you're serving, right? It's either this, or this, or this, or I'm sorry, I can't help you. Right? So if it's you enter this, now you do have to be careful because remember we talked about characters, they're actually stored as numbers. Uppercase letters are different numbers than lowercase letters. So an uppercase freshman is different than a lowercase freshman. So a couple things we can do about that. Generally, what I like to do is I will either lowercase everything or uppercase everything, whatever your preference is. I think lowercasing looks nicer because when I see things all in uppercase, I assume someone's yelling. Right? This is our internet convention. If you send a message in all uppercase, you're assumed to be yelling, and that it just makes me uncomfortable. So I don't want that. So I'm going to say, hey, I want this lower here, or is it too lower? Hang on. Too lower? Lower. Oh, come on. Oh, goodness gracious.
Dot lower, yeah.
Dot lower, thank you. Dot lower? Yes, dot lower. It's different in every language, and I always get confused. So I'm going to wrap all of this with, I don't even need to wrap it with parentheses, do you? So here's the input. Dot lower will take whatever they've typed in and make it all lowercase. Use dot lower, make string all lowercase. Okay. Now when I'm comparing now, I'll say, does it equal freshman, sophomore, junior, senior in all lowercase? There's other ways to do it. Once we get into the next chapter, we'll look at all the other ways. But I just want to get you started here with probably the easy approach. If you don't even want to bother, that's okay too. Right? We haven't got there yet. If you just assume they give you the right casing, that's perfectly fine too. Eventually, we'll have to handle all the uppercase and lowercase and weird things users give us. But this will probably mess you up if you're not being careful. So it's probably just a good habit to do. Okay, so let's give this a try. So let's see if we can do this now. Let's run our program. So we need 120 credits. We have 50. That means we have 70 left. If we take 13 per semester, we just get this calculation. That's great. Enter our year in school. How about we say first? And I don't know what you entered because it wasn't one of those. Sure, it hit the default case, the last else here. So 20, 50, 13. All right, how about now, what year should we say we're in school? Freshman. Welcome to UMD. All right. Very exciting. So that seems to work. So this is how we'll make the code do specific things based on things that were entered. So now our code can make decisions, essentially. They call these decision structures for people who like fancy terms. You can do different things based on values that were entered. Right? So that gets to be a lot of fun. Now, There's ways to draw pictures of these sorts of things. These when we're writing out code and thinking about code, a lot of times people like pictures. Pictures are a lot of fun. So what you'll get is a diamond. So the diamond is the decision operator. And you'll say, okay, we're going to branch. We're going to go this way if this is true, or this way if this is true. So we either have less than 12 credits, it's my credits times 606, or if you have 12 or more, it's your whole semesters rounded down times 72, plus your remaining credits times 606 for our calculation here. Right? So we can show this in a picture. We'll practice this more later when we start drawing more pictures. Some people really love pictures, flow charts and sorts of things, and there's a whole structured language around it called UML. It's in one of our outcomes. We're supposed to look at that. Eventually we'll get there. It's just not quite as fun to do. Sorry, my sugar is really high right now. I should not have had donuts for breakfast. That was probably a mistake as a diabetic. They're really good though. All right. And I forgot to make coffee at home. It was a day. It's a rough day. So I have 2 cups of coffee with me. I filled up on the way in. It's very fun. So eventually we'll get to these printing out pretty pictures. Okay. All right. So we jumped ahead just a tiny little bit in branching here. Let me go turn on some of these labs if you want to go work on some of these before I forget. That one's good. Highway numbers is good. Seasons is good. Exact change is good. All right. The golf scores one is dumb. We're not going to do golf scores. Probably because I don't like golf. But that's just me. That's a personal failing. All right. So I'll turn on those labs for practice 4. We'll get more into this stuff later when we go. There's other cool things we can do. We essentially did the if-else. That's all. That'll get you through the project. So for the project, right, I did add, let's see. So let's do next week, right, before class starts, because I'm going to go over the solution in class. So we're going to submit the URL, and we're going to add the screenshots of the program running. So I want to see that it ran, you got the screenshot. That's what we did in lab, right? We took the screenshot of it running, put it in the README file. So same idea. Now, I do have a class just before this one, so please don't wait until noon next week and tell me you're having trouble, because I'm teaching at noon. Okay? Is that fair? Next week's lab probably will have some time. Hopefully you're done by that then. Is that a fair goal? And if you have trouble getting it turned in and all the Git stuff, we're going to do it every lab for every lab exercise. I can help you with the project then. Wednesday before class. So my class starts at 11. I'm usually should be here by 10. Usually it's the wrong word. I'll try and get here by 10. If you got questions, you can catch me before my class, 10 to 11 or so, Wednesday next week, if you have trouble. It's the very first one, so I'm not going to be crazy. Like, if you've got it on your computer, great. We can figure out the Git stuff later if we need to. But we'll have had 2 practices by then. We should be able to do it. It's not the end of the world. Just have it on your computer. If worst comes to worst, you just show me that it's there before we start class, and we're good. Right? We'll figure out the rest part after, but we'll keep that in the back pocket. Hopefully we don't have to go down that route. And by next Monday, hopefully your project feels pretty good. You got most of it done. I can get you, make sure it works in the Git process, right? So you clone the repository, or you accept the assignment, you clone the repository that creates the folder in your computer, you make the project in that new folder, and then you can commit and push. You work on it, you commit and push, you work on it, you commit and push. When it's done, you take your screenshot, add it to the README file, turn in the URL, you're good. Then the last piece of it here is the rubric, right? I don't think I mentioned that, did I? Shoot. So we don't need to for project 0. It's really small. This is just a like getting started project essentially. But one of the other things I'll ask you to do for the other projects is score yourself on the rubric. Right? And the easy way to do that is take a little screenshot of it. This computer doesn't do this, does it? Shoot, I need the snipping tool. Goodness gracious. Okay, I can just put it in Paint. Paint is stupid. That's fine. Some sort of tool here. And then you can just mark here with your pen. Like, hey, I got 2 points. I got 2 points. I got 1 point. I got 2. I don't know. Any way you want to do it's fine. But you can't actually interact with the rubric in Canvas. I can when I score it, but you guys can't. So we'll figure out, if you just want to say, hey, for ask named, I get 2 points, that's fine too. But what we're going to do is you're going to assess yourself. And most of the time, you get your score that you give yourself. Folks are pretty good at assessing themselves. Like, hey, I got it all done. Or, I only got some of it done. Or I got none of it done because it was just a rough week. And that's okay, right? You don't have to get 100% on everything. It's not the end of the world. If you need to get a specific GPA for certain reasons, I know that is hard. Sure, there's all sorts of things there, but generally you can look through and this is your chance to be like, okay, great. So I did my ice cream, good. I did my drinks, good. I did my pizza, good. I did the number of guests, good. I got their name and I used it, good. Before you turn it in, you should feel good that you get 100% on it. That's sort of the goal. So I will grade right by this rubric. I can just check, it's done. That sort of thing. Occasionally you have problems in your code, and where you think you got 100%, you might only get partial points because it didn't do it correctly. Before the next project, we'll talk about a couple things we can do to make sure it works. For this one, honestly, I'm not too concerned. If the arithmetic is off, it's not the end of the world. This is not an arithmetic class. You need to be able to do correct arithmetic in Python eventually. But this is our very first one. So this should be pretty easy, pretty straightforward for everybody. Should be full points for everyone. If it's not, let me know. Right? If you get stuck on something, I don't know you're stuck until you tell me. So if you don't tell me, I don't know that you were stuck until you turn it in and say, oh, I couldn't get it done. And then I feel bad because you didn't get the points. And all you had to do was ask me. And most of the time it takes me 2 minutes to say, oh, hey, here's the problem you were having. Change this thing and now you can keep working. Most of the time, right? We can meet if we need to. We can set up Zoom calls. Turns out we're pretty good at screen sharing by now. Now in the post-pandemic world, we understand we can use these tools. They're not scary. We've been able to do it before, but people were scared of it. I don't know, for some reason, whatever. We'll make it work. So my goal is everyone gets everything done. That makes me super happy. It doesn't always happen, and that's okay. And we could be okay with that. But if you're stuck, again, generally try for a good half hour to an hour to figure it out yourself. That's a good habit to get into. You want to learn to problem solve, learn to figure things out. Some of these error messages just suck, and you have no idea. So that's fine. Just reach out and ask me. Or so searching online sometimes will work for you. ChatGPT is actually really good. Right? Go use the ChatGPT. Hey, Chat, here's my code. Here's the error I'm getting. What's happening? It can usually tell you, which is crazy. It's decent at it. The U of M tool, you get 5 chats per hour or 6 chats per hour. I forget what it is here. You can run out of them eventually. The free ChatGPT online, the OpenAI one is pretty decent too. That one I don't think is rate limited as often or something like that, but you get the better version with the U of M because they're using version 4 versus version 3, and sure. I'm just throwing numbers out at you. I'm sorry. It's not all that meaningful. But the U of M version is better. So I recommend them first, right? Then ChatGPT as a backup if you run out of questions, that sort of thing. Come to me, ask questions. You're welcome to talk to each other, right? You can, discuss in English what you're going to do here, right? Once you start sharing code or taking notes and writing code down, we've probably gone too far, right? Down that plagiarism route. But you can just say, hey, to figure out if they're going to have pizza, I'll say, did they enter the word pizza? That's literally what you just did with the lab here. But I said junior or freshman. Now I'm just going to swap this with pizza. That's literally it. And I'll have a bunch of stuff that happens in this block of code. Sure. That's it. That's how we implement this, right? But that's perfectly fine to discuss, right? But that doesn't mean, right, if someone says, I just want to look at your code and see how you did it, they don't want to just look at your code. They want to copy off you. Right? Tell them to go get lost nicely. And then we do have a tutor. I'm super excited. There's Andrew is our tutor. So he is tutoring in the Engineering Learning Center. This is the 2 doors down from the lab, HPEC 1190. So he's there 5 days a week. Holy cow. For a couple hours a day. Just sitting there. It's walk-in based. So he might have someone he's working with, but he'll be able to get to you or contact him. So reach out to him. He's a great resource as well. He will not solve problems for you, but he'll point you in the right direction. Similarly to what I'm going to do, oh, hey, have you tried this? Or let me help you with this error. That sort of thing. He's good at this. He's a great guy. So no additional charge. It's technically not free because it's paid for by your tuition dollars, but you don't have to pay more for this service, which is really cool. Okay, so take advantage of that, which is fantastic. This is relatively new with the Engineering Learning Center. turns out we've realized a lot of people like the idea of getting into the software field, data science or computer science or something related. And it's hard. It's hard for people. So we're trying to add additional services and tools and things for people to make you more successful. Okay? All right, I've talked at you for a little more than an hour. Any other questions, thoughts, concerns? We feel pretty good. So we've got the project coming up. If you didn't get the lab turned in, you have until next week, right? Generally, I'll go over it every Wednesday. Don't get into the habit of not doing it Monday, waiting till Wednesday, because the idea is the lab is your practice, right? If the lab doesn't go well, that's your clue that something isn't clicking, right? If it went okay, that's fine. It's not the end of the world. If it was super easy, great. But this is your chance to. So you're going to see me do it. You're going to read it in zyBooks. You're going to try it in zyBooks. You're going to do our lab exercise, and then we're going to work on other projects. Like we're going to hit this stuff over and over and over and over and over and over again. Okay. All right. Very cool. So we'll call it a day, and then I'll see you folks on Monday. So I'll hang out here. I'm going to head over to my office over in the CIS building. If you want to chat, or we can chat here till the next class comes in. But I think there is a class here at 2. Someone started coming in on Monday. But I'll be over in the CIS building if you want to chat more. We can go from there, okay? Awesome. Folks, take care.